Okay, this will be segment 2. I'm going to explain what the models from Hugging Face are and what the difference between the models from Hugging Face and a model that you might code yourself. At the very end of it, you'll understand what each of these parameters mean and what they contribute when you make a model. So essentially, to understand what the difference is, why you would go for a Hugging Face model as locally on your computer as opposed to coding one yourself or looking for more specialized or specific models, we would have to understand what the difference between each AI model is. This is the best one. There's no reason for me to even consider any other AI models, and you wouldn't be wrong actually. Most common use, you would just pick the AI with the most information or the most training or the most weights, and you're good to go. But for specialized use or for people who understand it a bit more technically, you might want to use another AI specifically for a specific task or something of that sort. I have written a document that mentions all the differences that you can very simply add. For example, you change one of these numbers, you change how the AI works completely. Make this 4 into a 12, your AI has completely changed. But it would have to retrain everything. So these are parameters you set at the start. Otherwise, the next time you train your AI, next time you want to use your AI, you'll have to redo all the training. And that's no simple feat. The training goes on for months on end sometimes for higher and smaller models, depending on the resources you have at hand. But to make your AI superior, you just change these numbers, and it's a super easy fix to just, yeah, here, I just want a better AI, make this number bigger. But obviously would have to train a lot longer. Okay, now the difference between, so I will go in the hierarchy of significance. I've tried to make it so that, for example, vocab size. This turns every token into a vector of numbers. Basically, every single bit of information that's put in here, as long the more you can break it down, think of an image. The more pixels it has, the more spread out it is, the better the quality of the final product, right? And that's true for every single item in here. But there's a different amount of gains. For example, a number of layers gains you a lot more than number of heads, but we'll get into that more as we go through it. So, vocab size basically grabs the tokens you have and turns them into a vector of numbers. There's obviously a bare minimum required to understand basic language, but you could turn this number way up so the AI doesn't give like a confused response, maybe doesn't understand something. So, the higher the vocab size, the better understanding of language it will eventually have, but it does have a cost of memory. It's always a balancing act. So you could say, oh, I want less training time, so you lower the quality. Oh, I want more memory, so it's just a balancing act of how much do you want in your quality, how much are you willing to sacrifice at the training. And that's true for every single step. There's a lot of steps where these decisions are. Okay, hidden dimension. This is basically the analogy I made before. Basically, it's the quality of representation that you give to a token. The higher the hidden dimension, the more pixels you have in your token, if I had to describe it. So you go from, for example, 1080p to 4K, but this is very costly because when you change this, because this is one of the starting factors, it trickles down and it makes everything a lot larger. But when you work with higher quality materials, you're eventually going to make a high quality building, if that makes sense. Okay, moving on. If you're familiar with the AI in this field, you may have heard of attention. This is basically what people mean when we get into attention. Number of layers. This is super basic. It's basically how many times your input gets processed. How many, like you put in a sentence, how many times it processes it and learns off of it. Very simple, very expensive, but it's very important to have this to have your AI learn in depth. The number of heads. Explaining this is a little complicated. I have come up with an analogy that I hope is easy to understand, but it is not entirely important. So this is basically how the information is processed. So imagine this is an analogy. So imagine a height, multiple heads attached to the same body, and they're all reading a book. Each of them understands the book slightly differently, but ultimately the knowledge that gets imprinted to the brain is the same. It's not entirely needed because the information gets learned either way, but it does help. And the cost isn't too much, but so it is recommended to have it, but having too many heads is going to be pointless because there's so many ways you can interpret it. It is a little bit more complicated than that, as you know, you could say that for every other topic, but I am going to keep it as simple as that for this topic because I believe that's enough to understand it. The block size, it affects it. The increasing this is very expensive, but it's going to give your AI a bigger context. The bigger models, like for example the older GPT models version 3.0, you know, it couldn't remember much, it had a low context, like the basically it would only remember the sentence before it at most, but that's memory. Block size is the amount of information that an AI processes given a context. This is very heavy to increase, so it increases exponentially the cost to increase it, but it doesn't help it very significantly. It is very noticeable. So in bigger models, with when you're expecting more comprehensive back and forth, this is very obvious. But for something more specialized, like a website assistant or trying to direct you to places, this wouldn't be entirely necessary. I have added a bit of extra information here. Feel free to skip this. It's not entirely relevant to everyone, but this is going to actually tell you why your RAM prices are going. So this, I'm basically going to explain what block and segmented learning is and what streaming is. So block or segmented learning basically loads all the information that the AI wants to learn into a single segment into the RAM that's ready to be processed. This helps the AI by keeping all the context, the back and forth is going to be very easy, and it's going to process the information much quicker. While streaming flows the data inside of the AI and it actively learns it and goes through it. So no RAM is required for streaming, but for block, it is required. And block is superior to streaming. That's why RAM prices are going up, and that's why it's so important. But I added this here just to say that block size still does matter for streaming because the model might generate one token at a time, but the token still goes back and reads over the entire history up to the block size limit. So there is still a context in streaming, even though you freely flow in knowledge, it is still relevant and has to be taken into consideration. So, this is a bit more specialized. You might not need to know this, but it does help in understanding how the AI understands and how it learns. So, QKV basically means query, what am I looking for? Key, what do I contain? And V, what will I contribute if I'm selected? This, from my understanding, is the knowledge, is a formula that all the AI models are using for their learning approaches. There is a library in Python called softmax that you put these informations into it and it gives you a probability matrix. This is a graph that identifies a relationship between all of the items, each of these tokens. This is where the weights are set, if you've heard that word before in AI design. This is where the learning actually gets finished and the model starts putting down its knowledge. The brain is forming at this step using softmax. So in these models, basically it's a glorified next word predictor This is just a probability. What's the probability of this next word being this? There are a bunch more ways that this is made more complicated. For example, there's feedback, like, okay, I go one step back and this word is good then, one step into the future. Basically, it goes back and it checks the previous and possibly even the future words to see, hey, am I doing this right? Am I saying these words correctly? An AI without those is just going to generate words and go on without double checking the words. So it's a little less polished. But this is basically where the forefront of the AI technology is at right now. This is where people are deciding the new logics, all the steps. New logic is being found. For example, something that's been, I've personally only recently heard of this, I haven't implemented it in my AI, is the grouping method where you keep K and V the same, but you get a new Q. But from what I've heard in the communities talking about this isn't entirely great for learning, but it does make it significantly faster and cheaper because K and V do not have to be recalculated at every step and they're just cached. But not recalculated every time does lead to some minor losses. But overall, the consensus is this is the superior version. Use this one. So there are a whole bunch of other stuff I could get into, like activation function, FFN, D-type, normalization, complex encode. These are all topics that you could get into. But like I said, this is the forefront of AI development. There are new stuff being constantly added. Knowing all this stuff is basically enough to know why the models are different from each other, why one model might be considered greater than the other one, because these parameters are bigger, but ultimately it's not entirely just about the knowledge or the size of the PTH file of the brain, because as you can see, there's a lot of factors. At every step, you could turn